Hi, everyone. Today we're going to talk about lesson 4, which is quantum numbers. This lesson is intended only for accelerated honors chemistry students. So this first slide says, what are quantum numbers? So as you can read, it says quantum numbers are a way of identifying the location, so both energy level, the shape of the sublevel that it's in, which orbital in that sublevel the electron can be found in, and finally, which direction that electron is rotating. So each electron has a set of 4 quantum numbers that are used to describe its location. Quantum numbers can even describe, as I mentioned, the orbital and the rotation or spin of that electron. And the other important part here is that quantum numbers confirm what we learned earlier about the Pauli exclusion principle, that no 2 electrons in the same atom can have the same set of 4 quantum numbers. So they can't exist in the same orbital, rotating in the same direction. If we look at the 4 different types of quantum numbers, the first quantum number is called the principal quantum number, and it states what energy level that electron is in. So it says the maximum number of electrons that can exist in an energy level is 2n squared, where n is equal to the energy level. So imagine if we are talking about the first energy level would have n equals 1. So 1 squared is 1 times 2 is 2. So first energy level has a maximum of 2 electrons. When we go to the second energy level, we have an n value that is equal to 2. 2 squared is 4 times 2 is 8. So we can fit 8 electrons in the second energy level, and so on. So if we go to the third energy level, we'll have 3 squared, which is 9, times 2 is 18. So you can start to see how these energy levels are building up. Okay. If we take a look at the second quantum number, so the second quantum number describes the shape of the orbital. So this is going to be, or the shape of the sublevel, including the orbital. So here we're identifying S, P, D, or F. And really the most important part about this entire slide is the middle part right here that talks about these codes. So if we have an S orbital, we're going to use the number 0 to indicate that. If we have a p orbital, then we have the number 1. If we have a d orbital, then we're using the number 2. And we won't go as high as f orbitals, so we don't have to worry about that. But if we were, it would use the number 3. So if we have a 1s sublevel, first quantum number would be 1, second quantum number would be 0. If we had a 3d, so we would say, okay, it's in the third energy level in the D sublevel. So the first quantum number would be 3. The second quantum number, which is called L, that's what that is up there. Second quantum number would be 2 based on this 2 here in the D orbital. Okay, let's take a look at the third quantum number. Our third number is known as the magnetic quantum number, and it's represented by a lowercase m and then a subscript of L. And as you can see here, it describes the orientation of the orbital in space. And really, there is only one orientation for an S sublevel. So remember that it's spherical. So there's really only one way to position that. There are 3 orientations for the P sublevel, and then there are 5 for the D sublevel. And then there are 7 for the F, but we're not going to talk about F. So what we do is we identify each orbital in a sublevel using a number. For the S sublevel, there is really only one orbital. So an S sublevel, remember, is spherical. So there's only one orientation that you could possibly put a sphere in. So for the S sublevel, we have a single orbital, and we're going to call that orbital 0. For the P sublevel, there are 3 different orbitals because that dumbbell shape can be oriented around the X, Y, or Z axis. So if you notice in the P sublevel, we always draw 3 boxes when we're doing orbital notation. So the box all the way to the left, we're going to call that -1. The box in the center, we're going to call 0. And the box all the way to the left, we're going to call 1. And finally, when we look at the D sublevel, we have 5 different orbitals. So for the box on the left, we're going to call that -2. For the box next to that, we're going to call that -1. For the box in the center, we're going to call that 0. And then to the right of center, we're going to call that 1. And all the way to the right, we're going to call that 2. Notice that the identification here says that the values for m sub L can go from negative L to positive L. So L is the previous quantum number. So for an S, that was a 0, so it can go from negative 0 to positive 0 or just 0. For a P sublevel, L was equal to 1, so that means m sub L can go from negative 1 to 1, as you can see here. And then for a D sublevel, we said that the L value was equal to 2. So the values for m sub L can go from negative 2 up to 2. All right, and finally, the last one that we're going to talk about is called spin quantum number. So if the arrow is pointing up, then we're going to use the value positive 1/2. And if the arrow is pointing down, we're going to use the value negative 1/2. So I'm going to take my little arrow here. We're going to just spin this so that for up, an up arrow, we're going to call that positive 1/2. And then if we have a down arrow, so I'll spin this around, we're going to call that negative 1/2. So depending on which electron you're trying to identify or which one you're drawing in, it's either going to be an up arrow or a down arrow. Up arrow we'll call positive 1/2, and a down arrow we'll call negative 1/2. Okay, let's have a look at some examples of what we're talking about. So for the first one, it says, how will we use this in class? So we're going to either be given a set of 4 quantum numbers like we are here, or we're going to be asked to identify a set of 4 quantum numbers for a particular electron. So let's look at the first example. We're given a set of 4 quantum numbers, and we're asked to figure out where that electron would be in this orbital diagram. So first part, we have the first quantum number, which is n equals 3. So this means that we are in the 3rd energy level. So those numbers out front, again, represent energy levels. This tells us that we're in the 3rd energy level. The second quantum number, remember, tells us whether we have an S, P, D, or F. So S is equal to 0, P is equal to 1, D is equal to 2, F is equal to 3. So since we have an L equal to 1, that means we're talking about a P sublevel. Okay, now the next one talks about which orbital in the sublevel. So if we think about what a P sublevel looks like, which is, we have the 3p in this case, if we have a value equal to 0, remember these are -1, 0, and 1, that means we're talking about the middle orbital in the 3p sublevel. So middle orbital. And then finally, the last one is a -1/2. So that means our arrow is pointing down. So if we are to identify this electron, we're going to go to the 3rd energy level, which is right here. We're going to go to the P sublevel. So that's this one right here. We're looking at the middle orbital, again, because this is -1, 0, and 1. And we're looking at the electron that is pointing down. So this electron is identified by this set of 4 quantum numbers. The other possible thing that we're going to be asked to do is to identify a set of 4 quantum numbers for a particular electron. So in this case, I have pre-selected this electron here in the 4s sublevel, the electron that's pointing up. So when we look at our 4 quantum numbers, if we're in the 4th energy level, that means the first quantum number is going to be a 4. If we are in the 4s sublevel, then the second quantum number has to be a 0 because that's what is represented by S. And then the only possibility for an m sub L value, if we have an S, is another 0. And then finally, because we're talking about the electron pointing up, we're going to have a value of a 1/2 or +1/2. Now we're going to practice a few of each of these. So first, we're going to practice 3 examples where we are provided quantum numbers, and we're going to try and identify which electron we're talking about over here on the right side. So let's take a look at our first example. We have a 2, 0, 0, 1/2. So 2 means second energy level. L equal to 0 means we're talking about an S sublevel. Remember again, S equals 0 is for L. S equals 0, P equals 1, D equals 2, and we're not going to go above that. If this is a 0, then this automatically has to be a 0 here, and then positive a half. So in the 2s sublevel, the electron that's pointing up. For our second example, we're going to look at an energy level that is equal to 3, a sublevel, 0 is S, 1 is P, 2 is D, so we're looking in the 3D sublevel. Remember, the 3D sublevel has 5 boxes. So if we have a -2, a -1, a 0, a 1, and a 2, this -1 tells us that we're in this box right here, and we're the arrow that is pointing down. So in the 3D sublevel, the second box in pointing down, this is example number 2. And then finally with example number 3, we have the 5th energy level. L is equal to 1, so that means we have a P sublevel. In the P sublevel, remember we have 3 boxes. We have -1, 0, and 1. So since this is a 1, we're talking about this box over here, and we're the arrow pointing down. So in the 5P sublevel, all the way to the right, arrow pointing down. So this was example number 3. So now what we're going to do is take a look at an example where we have 3 electrons that are identified for us already, and we're going to try and figure out what their set of 4 quantum numbers would be. So for the first example, we have the red electron, which is located right here. So we're in the 3, third energy level. So we're going to write that up here. We are a D sublevel. So remember, S is 0, P is 1, D is 2. So we're a 2 there. In terms of which specific orbital we are in, this is -2, -1, 0, 1, and 2. So this is the 1 spot. And we are the electron pointing up. So that's going to be either a half or positive 1/2. Let's take a look at our second example. So in our second example, which is right up here, we are in the 5th energy level. So we're going to say that N is equal to 5. It is a 5P sublevel. So for P, the value for L is equal to 1. The value for M sub L is the specific orbital, so -1, 0, or 1. So we have a -1 in this case. And it is the electron pointing down. So we have -1/2. Our third and final example looks like this. We have our green electron, which is located right here. So we're in the 3rd energy level, in the S sublevel. So 3 and then 0. Remember, for the S, since there's only 1 box, there is only 1 possibility, so this is also a 0. And then the last part, the electron is pointing up, so we have either positive 1/2 or just 1/2. Okay, we are now looking at the quantum numbers practice sheet. What I wanted to do was show you an example of what I am asking you to do for homework. So there are 6 problems in the first section of this, and there are 6 problems in the second section, and we're going to do 1 of each type of problem. So if we look at the first part here, we have, for problem number 1, a 4th energy electron in the S sublevel. So once this is 0, remember this one also must be 0, pointing upward, so a 4s pointing up. So what I want you to do for this is double click on the drawing, then somehow indicate that 4s electron. So I've found that the easiest way to do that is just by putting a box around it. So I'm going to create this box here around the 4s electron pointing up, and a couple of things you can do. So you can make it transparent so you could see it a little better. You can also make the box around it a little thicker, and you can also change the color of the box to make it stand out a little bit. And then the only other thing that I'm asking you to do is to somehow identify that box. So we're going to put this is the answer to number 1. So again, we can identify that box once we close this. So if you notice, I have now, if I click off of this picture, I've now identified this box here as the answer to number 1. So I'm asking you to do that for the 5 remaining problems here. We took a look at numbers 7 through 12, you'll notice that just the opposite is what we're doing. So I have identified 6 electrons. We're going to look at number 7 here, and we're going to come up with the set of 4 quantum numbers for this electron right here. So we are in the 5th energy level in the S box. So down here, we're going to write a 5, and for L, that's going to be a 0. And then of course, since the S sublevel only has 1 box, this will also be a 0. And then since we were talking about the electron pointing upward, we're going to write in here either 1/2 or positive 1/2. Okay, so that wraps it up for our quantum numbers assignment. If you have any questions, please let me know. Thanks very much, everyone.